Okay, good morning. Welcome to
KidMath number 141.
KidMath number 141. Now, we were doing a different project this morning, so we actually didn't talk at all about our art of problem-solving math. So I'm just going to work through this example for you because it's the first example in the next section. Well, I changed the numbers around. Okay. So Bill borrowed $3,000. The interest rate is fixed, means it just stays the same for the whole time. It was compounded annually for 5 years. At the end of 5 years, he had $5,000. What was the interest rate? Okay.
Mm-hmm.
So this is actually a very common problem that you have to solve in anything where you're borrowing money. Okay, so it's a pretty neat example. So we're trying to find the interest rate, R%. So we know from year 0 to year 1, we started at 3,000, and then how much, if it compounded at R% for 1 year, how much would he have owed?
3,000 times 1 plus R%.
I'll just write it as R to the first power. At the end of the second year, how much would he have owed?
3,000 times 1 plus R squared.
And dot, 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 all the way down to year 5.
3,000 times 1 plus R to the 5th. And this equals $5,000.
Okay, very good. So we have to solve this equation. 3,000 times 1 plus R to the 5th equals 5,000. Okay. What do you think would be a good first step in solving this equation?
Well, if we divided by 3,000, we'd get 1 plus R to the 5th equals 5/3.
5/3, very good. Okay. And now we have an interesting little problem to solve.
Multiplying this out is going to be hard.
Multiplying that out is going to be very difficult, and in fact will produce a 5th degree polynomial, which we don't know how to solve anyway.
Yeah.
It turns out that was... Have I ever told you the story about Galois?
Yeah, I think so.
Okay, so Galois was a young, he may have even been younger than 20, but let's just say he was 20. He proved that polynomials of 5th degree and higher don't have general solutions. So there's no such thing as the quintic formula, as analogous to the quadratic formula. So you might not even be able to solve this at all, but this is in a nice form right now. It's almost like a completing the square form, right?
Yeah.
So we can take the 5th root of both sides of this equation. What is the 5th root of 1 plus R to the 5th?
1 plus R.
1 plus R. What is the 5th root of 5/3?
It's just the 5th root of 5/3.
It's just the 5th root of 5/3, and for that we're going to need a scientific calculator. And luckily, my phone has one. So, let's see, utilities, calculator. So we'll go 5 divided by 3, which is 1.66666666. And we're going to do that to the power of 1/5. So in what decimal is 1/5?
It's 0.2.
So we take that to the 0.2 power, and we get 1076,
Alright.
approximately 1.1076.
So R
R is approximately what?
0.1076.
0.1076. So what was the percent interest rate on this loan?
It's what they said. Did they say it? Oh no.
What was the interest rate? So as a percent, what was the interest rate as a percent?
Well,
What is
it's
0.10?
10.76.
10.76%. Okay, so that's interesting. So at 10.76% interest rate,
You earn exactly.
a $3,000 loan for 5 years, you have to pay back $5,000. So in 5 years, there's $2,000 of interest. It's a lot, right?
Yeah.
I mean, you only borrowed $3,000 to begin with, and you have to pay back the $3,000 plus $2,000 more of interest. The interest really adds up.
Yeah.
Pretty cool, right?
Yep.
So this is, like I said, this is a very common kind of problem that you encounter anytime you're borrowing money. how much interest am I going to have to pay back? So this, in terms of daily life and things that you're going to, do, like later on, if you have credit cards or a mortgage, or you have to take a car loan or something like that, you have to do this kind of math to understand it. Pretty neat, right?
Yep.
I don't think they make Lego loans yet. Not yet.